Welcome back. Today is day 33, daily LeetCode adventures. I don't have much sleep. I'm on low sleep, but I am excited to dive into some problems. I'm definitely thinking today's a revision day. I need to be mixing in revision with new problems. I'm excited to get to the end. I'm excited to have more problems to solve. I'm excited to be a level where I can solve any problem at any time. That'd be pretty cool. That being said, reflections on yesterday. Yesterday was actually a pretty good session. I actually experienced some interference, I think. We're doing a two-sum problem, and I could feel the different solutions in my head. It was interesting because the solution that you actually end up using mostly depends on the edge cases that are being checked, basically. So that was interesting. And I also realized that I need to add a notes feature. I need to be able to look at a problem because I'm juggling so many problems now. I need to be able to look at a problem and know exactly what I'm working on in regards to the problem. That being said, that is coming soon. I want to get that out soon. And then, yeah, maybe we'll see where we go from there. But I'm feeling pretty confident about that. There's not really any cards due today. But there is a lot of revision to be done. And I'm thinking today might just be a ton of revision, honestly. Maybe 45 minutes. Honestly, the whole day might just be revision. I'm noticing that I'm behind on a lot of revision, and that really is the way to go fast. I mean, someone said, I don't know who said this, but someone said if you want to go fast, go slow. And I think the intuition behind that is maybe that ideally if you're going slow, you're getting the depth that you need so that you don't have to actually rush. And the more depth that you have, the more you can do with less, the more you can do with what you have. So that being said, let's jump into the problem. Make sure to join the Hyperbolic Coding Chamber Discord, and at the same time, if you're doing a similar journey, if you are practicing LeetCode, if you're doing something else daily, let me know. Drop a comment. That would be cool. Maybe we can exchange insults. Maybe we can exchange compliments. That might be kind of cool. But yeah, I'm just joking. But yeah, I'm gonna jump into some problems. I don't know exactly how much revision we'll do, but I'm thinking a significant portion, to be frank. A significant portion of revision, followed by maybe longest palindrome or O1 matrix again. You know how it goes. So maybe we can intuit O1 matrix, and then from there, I think we have something that we could work with. So that being said, let's jump into the revision. Maybe we'll do 50 revision, 50 new. Maybe we'll do 20 minutes of revision, then 20 new. We'll see. So let's jump into it. So balanced binary tree. Given a binary tree, actually, change of plans, we're going to do one new problem and then do revision off recording. Just some things that have changed. Still going to do an hour and a half today, but it's going to be 30 minutes. I think it has to be 30 minutes on camera and some revision plus some dev work I have to do off camera for the spaced repetition application. That being said, looking at the grind 75, there's a few different things you can do here. I just messed around with the order, and so we're stuck on O1 matrix. I kind of want to do k closest points to origin and then keep going. But I keep moving these around. I should probably stop. If you order them by difficulties, what we were doing before, then it kind of just goes like this. I think that's what we originally had. If you do all rounded, I'm not really sure what you're getting here by doing it this way. Group by topics, do by difficulty. If you do no grouping, I mean, what is going on here, right? So yeah, I'm not certain. So we're just gonna go like this, honestly. And then either way, k closest points to origin is the next problem. So let's try that. With 30 minutes on the clock, I don't even know what a heap is. So it's probably just gonna be a struggle for 30 minutes, and then we're gonna see what the answer is. Or we will do 20. Oh yeah, 30 minutes to recommend. So that's what we'll do. So we have a function k closest, and we have a matrix of numbers. We have k, which is a number. We're returning a matrix. Given an array of points, where points of I, so we have an array of coordinates equals xi, yi represents a point on the xy plane and an integer k. Return the k closest points to the origin 0. The distance between 2 points on the xy plane is the Euclidean distance, i.e. square root of x1 minus x2 squared plus y1 minus y2 squared. And return the answer in any order. The answer is guaranteed to be unique except for the order that it is in. So we have points 1, 3, -2, 2. Right? We have 1, 3, -2, 2. And we're supposed to return the k closest points to the origin. So they give us 2 points in k, so the 1 point that's closest to the origin. Distance between 1 and 3 and the origin is square root of 10. Distance between -2, 2 and the origin is square root 8. Square root 8 is less than square root of 10. -2, 2 is closer to the origin. We only want the closest k equal 1 points from the origin. So the answer is just -2, 2. Why is so it's not really a matrix, it's just an array of points, an array of tuples basically. So they give us 3 points, they want the top 2 closest points. The answer would be 2, 4, 3, 3, and 3, 3, 2, 4 would also be accepted. And k is always greater than or equal to 1, which is less than or equal to the number of points length. So we never have a case where the number of points we have and the number of points we're supposed to return are different. xy can be -10 to the 4 up to 10 to the 4. So why is it So are there any clarifying questions we can ask? Let's imagine we have 100 points and our k is 5, right? Let's just see if we could have up to 1. If we have 10 to the 4 points, sorting that would also be a little crazy. So maybe after a certain point we can actually, well, do we have to, right? If we had to sort 10 to the 4 numbers, that might take a very, very long time, right? N log n time. So if that's the case, your answer is guaranteed to be unique except for the order that it is in. If that's the case, right, then how could we go about doing this, right? Because we probably don't want to sort. So initial naive solution that I'm thinking is iterate through points, calculate all distances, sort, return top k, right? We return the top k, that'd be the k closest points to the origin. If we do that, that is a lot of numbers to calculate distance for and a lot of numbers to sort, right? So how could we go about this? Is there anything we can intuit from the x and y values per chance? What if we say, if we look at this kind of circular, maybe what we could do is actually, instead of having to do this all in one, well, if we have to return the top k, like the k closest points, then we have to visit every number, right? And so I'm curious actually, if I just do, if we just try and sort points, right? And it's a pretty much, tuples. We'll say call it T1 and T2, right? We'll say T1 sub, right? And what would we like? I'm just curious, if we try this, maybe we'll run out of time. We'll call it ED for Euclidean distance, right? And we'll take, let's see, x1 is a number, x2 which is a number, y1 which is a number, y2 which is a number, and we're going to return a number. We're just going to return math.square root of x1, right, minus x2 plus y1 minus y2. And we're going to take the entire square root of that square root of that, but we want to do this squared, and so we also want to square this one. See if all the parentheses line up, so that makes sense. And so the origin is 0, 0. So we could do t1, right? We want to call our ed function, right? We'll say ed for the Euclidean distance of t1, right? Sub 0, t1 sub 1, right? And we'll have 0, 0 minus ed of t2 sub 0, t2 sub 1, 0, 0. Even our original example only has few numbers, but we could return points dot slice. So we're getting, so we're doing the distance. So points should be sorted. We print points. So maybe our Euclidean distance is slightly off. We double check, we have the square root of x1 minus x2 plus y1 minus y2 squared. So we're taking the square root of that. Oh no, the way we pass it in, yeah, the way we pass it in was strange. We should have did x1, y1, and we do x2, y2. So x1, y1, x2, y2. That makes more sense. So we should run out of time, I believe, because sorting up to, wait, huh? K closest points to origin should be unique. So actually, I'm not exactly certain what is. Maybe I overthought this problem. I thought it was a medium. K closest points to origin. What exactly is? I mean, this time complexity is a little bit crazy though if you think about it. If you have the 10 to the 4 elements, right? I mean, I guess the time complexity is bounded by the sort, which would be n log n time. Then you return the top k elements. So I honestly feel like there's something I'm missing here. from each side of the equation, which will significantly reduce the overall. You can also simplify the process of comparing 2 points by using the squared Euclidean distance instead of the precise Euclidean distance, as both will yield the same results. This allows us to remove the square root from each side of the equation, which will significantly reduce the overall computational time for each comparison made. Custom compare is what we did. So max heap or max priority queue seems to be the secret sauce here. N log n to the sorting of the points, space complexity for the space required by the sorting process. So max heap or max priority queue, these data structures allow access to the max value in constant time and perform replacements in logarithmic time. Simulate max heap functionality in a min heap data structure by inserting negative this instead of this if necessary. At the start of the iteration of points through points, we'll insert the first k elements into our heap. Once the heap is full, in the comparison of point to the farthest point stored in the heap, the new point is closer. New point is closer, then we should remove the farthest point from the heap and insert the new point. After the entire points array has been processed, we can create an array from the points stored in the heap and then return the answer. Use a max heap or max priority queue to store points by distance. So the first k elements in the heap, then only add new elements that are closer than the top point in the heap while moving the top point to keep the heap at k elements. Return an array of the k points stored in the heap. So does JavaScript just have a max priority queue automatically implemented? With point of points, alright, that this equals squared distance. Max pq.size is less than k for the max pk up to k points and queue it, right? But if the new distance that we calculate is less than the front dot priority, and the priority I guess is max, the max pq is full and a closer point is found, discard the farthest point at this one. PQ and Q point this. Return all points stored in the max PQ. This would be n refers to the length of the given array points. Time complexity would be n of log k. Adding to / moving from the heap or priority queue only takes O log k time when the size of the heap is capped at k elements. Approach 3. It's probably asking us to identify the first k sorted points. Another approach that may come to mind is a binary search. Standard binary. I see. So we just keep searching through. Let's see. Sort of the range values to attempt. Binary search. This would still be n log n. I see what they're getting at. Interesting problem. Let's try longest substring without repeating characters. This one's supposed to take 30 minutes, so let's try that. So we have function length of longest substring s, returning a number. Given a string s, find the length of the longest substring without repeating characters. Given a string s, find the length of the longest substring. So we have to return the length, the longest substring without repeating characters. Interesting. So ABC, first we have ABC, that's 3, right? Then we have A again. Then boom, that is bad because the answer, because what we have then is A repeating, right? And we didn't want that, right? So the best we can actually do is 3. So initial ideas, we're reading through the examples, right? So the first example makes sense. Let's look at S. Here we have B equals 1, B equals 1, B equals 1. So the answer is B, right? Because every time you start a new string, you run into another B. We have P, W, W, K, E, W. The answer is W, K, E. It looks like there's actually not a unique answer to this because another valid answer could be K, E, W. Notice that the answer must be a substring. Huh? Oh, P, W, K is a subsequence and not a substring. S consists of English letters, digits, symbols, and spaces. So this one is interesting. I'm trying to think of some other counter examples. So I'm thinking of an algorithm which would run in linear time, right? Sliding window style, right? We'll do a math.max for length, right? Iterate for every character, right? And we'll also have a map. I guess we'll also have a set. Iterate for every character, right? If C not in set, right? If C is not in set, C is not in a set, that means we can add, right, it to the set, right? And then we'll do the math.max of the max and the size of the set. If C not in set, add to set. But if else, right, if it is in the set, right, what do we want to do? We want to pop that character off, right? So we'll pop it off. So we pop the character. So if we were at A, B, C, right, we'd run into A, we'd pop A off, right? But I think the other thing we want to check, right, if we're popping it off the end, that's fine. But if we're popping it off the center, if we're popping it off anything that's not, if the letter that is in the subsequence is not the last letter, right? So we'll have two cases, right? If car in set is the first car, right? Remove C, right, from, this is if C not, so wait, what? This is if car is not in set. If car not in set, add to set, right? So this is else if car in set, right? We have two cases. If car in set is first character, right, then remove first car. Wait, so let's say we run into A, right? We could remove A from here, but it probably doesn't matter. Actually, no, yeah, we could remove A from here. Right, so remove car from first set, right? And then we would add remove first car from the set, right? But if we're going to add it back, so I think the thing is, if the car in set is first character, then we're actually fine, right? We actually don't want to do anything. That is okay. But else if car not first car, right? So let's just say you run into, like, let's say we go A, B, C, right? Ran into B, right? We can't remove you can't just remove B, right? Because then we'd have a subsequence. We want to remove all the characters up to B. And if we do that, right, then we could just keep the B that we have. So else if car not first car, remove characters up to current car IDX. So we want to move characters up to current characters IDX, right? If we run into B, we would remove 1, 2, which would be B here, right? And then we have cab, right? And we have C, we remove first character. We don't want to do anything, we actually just ignore it, right? Then you run into B. Well, B is actually not our last character. So we want to move everything up to B. Same thing if we ran into C, right? And let's just say we had A, B, C so far, right? We want to move everything up to C basically and just restart. And then we can keep going. So I sort of feel confident about this. It only consists of English letters, digits, symbols, and spaces. Can we create a counterexample that would destroy this? Let's say we have something like A, B, right? We'd say A, right? And so our length would only ever be 1 because we're just repeating, right? We said if iter of every character, if car not in set. If the car is not in set, it is, right? And if car in set is first character, which it would be, right? So we just wouldn't do anything. We keep going until we get to B, right? This would be the character that's not in set, add to set, and we constantly doing a math.max throughout. So let's try to implement that. So we want to iterate for every character. So we say for const C of S. Right, we're going to have a let max, right, which is going to be our max length. And since we're taking the math.max of it, we're going to start it at negative infinity. And is an empty string part of the output? We're not certain. It looks like S can be 0, right? So in that case, right, they don't exactly tell us what we should do in that case. Say if S.length equals 0, right, the length of the longest substring is 0. So we're going to iterate for every character, right? We want to know if the character's in the set, right? So we're going to need a set. We can delete this. We'll say set equals new set, right? It's going to store strings, which are basically characters. All right, so we have the max and the set, and we want to say, right, if C or if set.has C. Right, so if set has C, right, you want to add it to the set. No, if set does not have C. Actually, it might be simpler if the first case is not the case that we're not exactly too concerned about. So we'll say, now we can change this to else, basically. And I think this is just easier to read. We'll say if set.has C, then we can do this. So if set has the character, right, there are two cases. If the car in set is the first character. So how do we know if the character in the set is first character, right? And my second idea that's coming to mind is we could use a map to map the character to the indice, but that wouldn't exactly work. Or maybe it would, right? If we mapped the current character, right, to an indice, then if we wanted to check if character in set is the first character, we could get, we could look up the indice. So let's just say we had A, B, C. We could check. We got to A. We could look up A in the map. We get index 0, and we'd be at C, right? And so we could say C, which is the size of the set, 3 minus does 3, or the current index, right? Right, so we could do the set's length. We do the set's length, the map's length, so 3 minus our current index, and we get the first character. Then we don't want to do anything. So how can we check if it is the first character? If we use a map, we could map it to an index. That index would be 0. The index, something is off. I'm getting something is off about this implementation to me. The current set is the first character. Obviously the set doesn't have. The set is just binary checking, right? In constant, hopefully amortized. Constant time, basically. Amortized constant time. But I guess if the map, how do we know if the character in the map is the first character? So we're iterating through A, B, C. We get to A, right? This is index 4. Right? If we had a map, we'd have A, B, C set to 1, 0, 1, and 2. If we have it set to 0, 1, and 2, how could we know from index 4 if A is the last character? If we look up A in the map, we would get index 0. How do we know that's the last character? I think what we want to do is actually the opposite. What if we map the current indices to the letters? So we would have something more like this. 0 equals A, 1 equals B, 2 equals C. And so once we get to A, right, we'll say, oh, A's. We could also keep a set to know what's in the map, right? So we could say, would say, is A in the map? Well, it is, right? And if that's so, if we do it like this, then what we could do is if we do the map size, right? So we would be at A right here, which would be index 4. We could do index 4. So are we at index 3, 0, 1, 2, 3? We could do index 3, right, minus the size of the map, which would be 3. We get index 0 in the map, which would be A. And if they're equal, that means it is the first character. At the same time, maybe it's even simpler just to find a easier way to do the first character. How do we know if something is? Yeah, I think this might be the only way by chance. So what if we set up a map, a new map of number to string, right? And we want to map the indices to letters. So we'd actually have idx c of s dot entries. Or maybe we want to spread string into an array and then do s dot entries, so we can actually get the index. And so we could say if set dot has c, right? Well, it's the first letter A, right? So what do we want to do? We could say map dot set, right, idx to c, and additionally we would say set dot add c. So we'd have 0 mapping to A, and we'd also have a set to know immediately whether or not we've seen this character before, right? Then we get to B, right? We map B, which would be 1 to B, right? We add it to the set as well. We get to C, right? Gets set index 2, right? Gets set to C. We add C to the set, and then we get to A, right? If the set has C, it does, right? We want to do something if the character is not the first character. So you want to know if it's the first character. So we say is first car, and we pretty much need to do the current index we're at, right, which would be index 4. So we could say IDX, right, IDX, which is index 3, right, index 3 minus map or set, they'd be the same here, map dot size. I don't know if it's a method or a property. We'll say map dot size, which at this point would be 3. So we'd have index 3, right? And then so we could say last car I just realized we don't exactly need the map because we can just I don't think we actually need the map because we can just look it up with the set. We could say if the set's IDX minus the set size, right? We can actually just get first IDX. And we could say last car equals S dot car at first IDX. And then we could just say if C does not equal last car, right, they want to remove characters up to the current character index. Right, in this case, A actually is equal to it, so we actually don't do anything. But in this case where we get to B, right, B would no longer, right, we go to 0, 1, 2, 3, 4. 4 minus the set size, which would actually be 3, gives us 1, right, which was not the first we do 4. Maybe it's simpler if we just keep a temporary string. Keep a temporary string. If we keep a temporary string, then we add things to the set. We do temp plus equal C, right? And if we want to know if something's less character, when we get to B, what we can do is we'll know that, right? We'll have A, B, C. And then we won't do anything because it'll be A. Then we get to B. So we want to check if C is not equal to the last character. It is, so we don't do anything. And then we do B, check if B is equal to the first character. It's not, right? And since it's not, we'll have to remove characters up to the current character index. Right, and so the way we're checking for first actually does change. What we can do is just do if C does not equal temp car at 0. And this is safe because if the set has a value, the set has the character, then we must have a character in temp. Remove characters up to the current character index. So in this sense, our temporary string will store A, B, C. We want to move characters up to B. We have A, B, C. We want us to remove characters up to B. and I think we could do that. Move characters up to the current, not the character index, the current character. It actually might just be simpler if we make this an array. Easier to iterate over it. Temp.push C, move character. So we'll say for let I equals. So we basically want to move characters up to the first B we find. So we can say let car equal temp. So 0, and then we'll just do while car does not equal right, while car does not equal, so temp car at 0, so while car does not equal C, which is the current character, which is B, right? Then we want to do temp dot temp dot shift, right, which would remove the current character. This is a strange way to do it. So we'll just say let idx equal 0. We'll say while temp sub idx is not equal C, right? Then we want to say temp idx plus equal 1, right? And then afterwards you can say temp we'll do temp dot splice, right? And we'll start at index 0, right? And I think the splice API looks like start index and delete count. And so the delete count here, if we start, so we'll start at index 0, right? Does A equal B? No, so index plus equal 1, right? Does B equal B? Does B not equal B? No, because B does equal B. So we go out, right? And basically we want to remove one character, which is going to be idx. And so or we could also do temp sub 0, temp sub idx. Basically we're just in the cotton, like a bit of a weird spot, because if we also have to we would have to fix what we did to the set. We have to fix what we did to the set. So we'll have splice, and then we just check the splice API quickly. Alright, so I checked it. IDX is actually the delete count. Alright, so we actually don't want to set it. We'll just call this deleted, and it returns an array. We say for const C of deleted, right? I'm going to say set dot delete C, or set dot remove C. I think it's delete. So we'll get to B. All right, we'll delete one character, which would be A. And so we're actually going to want to delete idx plus 1, because we know the character exists. So we want to include the character that we're deleting, which would be B, and then delete would be A, B. We have C, A. Oh, no, because we want to keep, right? So actually, we want to keep the character, right? Since it's the new first, so it's IDX. And so, okay, so then we would have B, right? We'd have C, right? Then we'd go up, delete B, right? We'd keep C. Then and throughout this entire thing, we'll be taking max equals the math.max of max and the size of the set. We can return max. So we run this for B, const IDX of C, right, with the entries, right? Does the set have B? It does not, so we push B onto the set, we push C onto temp, go to the next iteration, we go to B. Does the map have B? It does, right? Is the car the first character? Yes, right? So we let IDX equals 0, while temps of IDX not equal C. So we actually don't, so while temp IDX not equal C, so does, while B does not equal B, right, but B does equal B, right, so we do constantly equals temp dot splice 0, and we don't delete anything, right, and this is actually fine, because then we would just keep doing this over and over, B, 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 never actually adding to the set. And if we do this for P, W, K, K, we add P, right, then we'd add W, then we would check, hey, is W in the set? It is. Is it the last character? It's not. It's not the, right, it's not the last, wait, is W the last character? It's not, right? So IDX equals 0, right? Temps of IDX, while P does not equal W, so we add 1, right? We delete 1, delete it from the set. Now we just have W, right? And temp again, we check if K is instead, it's not, E, then W. So actually, let's try this. And I forgot we changed temp to an array. We're doing splice here, temps of IDX, so it works for the first test. Let's see if it works for the so my output was 2. We have A, B. Right, we start here, we go back to B, we have A again, so we delete up to A. Alright, A again, but A isn't the last, so we delete up to A. Then we have D, exclamation point, so that would be 3. And then we would have B, so we should have gotten the right answer here. So I'm wondering why that is. So I'm going to take this one, see if we get the right answer. Okay, so we get it like that. So there's something about this AABAA. What if we do like this? Okay. What if we take out the extra A? Oh, I think I see. I think I actually do see what the problem might be. We delete it from the set. Oh yeah, we did splice it. So once we add this A up front, yeah, something's happening here. If we had this A here, do we get the wrong answer? So then we have this B. Yeah, I'm actually. Is it the literal exclamation point? No, this seems fine. So I actually don't know why this isn't working. I wanted to isolate the issue, but it seems like it might be an arbitrary thing. So okay, we have A. Does A exist in the set? No, so we add it. Then we take the max of max or set.size, which is 1. And we add A. We check if the set has C. It already has C, right, which is A. All right, then we say, does C not equal sub-0? It does, right? So we're gonna skip this, right, and take the max at set.size. Then we get to B. We say, okay, is B in the set? No, so we add it to the set and we push C, and then we're like, okay, now set has a size of 2. Then we go up to A and we say, hey, does A exist in the set? It does already, right? And is it the first character? No. It doesn't. I mean, it's not the first character. Oh, no. Well, does A, well, it's not the last, it's not the first character. So we keep going. We've already repeated. So I think if you get to A up here, it's still the first character. We get to a second B. So we go all the way to the front, right? IDX sub 0. And while this index does not equal B, A does not equal B, that's 1. A does not equal B, that's 2. A equals B, so we have 1, 2. And so we stop. I'm gonna move these from temp. The leak count there is 2. We delete A from the set. And then we get exclamation point, which is not in the set. So we add that, so we should be at 3. So we have A, AB, AB, then we remove A, we add B, A, we have on the set, so we add it. Might make more sense if we get the better picture just by printing it every. So you have A, then we add B, which would be AB. Then we have A, we have A. We run to the second D, we should still have an A. Should still have an A, but we don't. Oh, because A removes it. I think I see what's happening. So I think the approach just doesn't work. And we should treat it more like a sliding window like we originally planned. So if we iterate through the string, we try to add something to the window, and only the right window is ever moving forward. And so if we get A, right, then we basically want to restart at A. And we see it again, we'll just restart. So I think that's actually the simplest way to do it. We can keep the set, we don't need temp. Don't need all this, right? Because if it's in the set, right, then we want to remove it from the set. Else, if it is in the set, then else if it's not in the set, then we want to add it. Here we don't need temp anymore. We don't need the index either, I think. So let's try with this. We'd have A, right? A is not in the set, so we add it. Then we go up here. A is in the set, so we delete it. Then we go here. That's why we can't. What if we decide to throw it away when the current index plus the next index is also A? All right. B A A B exclamation point B B. Without repeating characters. What if we just iterate through the string? If we run into, we already know it's in the map, then we'll keep the problem is we can't really know until after. We want to delete one of them, not all of them. Not all of them. So maybe we change the set to a map, and then if it is inside, we decrement one occurrence of it. If it is in the set, we decrement one occurrence of it. And if that makes it goes to 0, we delete it. Or we'd still have A, B. Add A, right? Then we could remove one. Then we add another one. And then remove one. And then we'd have add B, and then we'd remove B. We have an exclamation point, which would finally give a size of 3. So I think we could do that instead. Just do a map. This would be a map of string to number. So for constancy of S, we always add a character to the map. Map.addC, and we get the value of C, otherwise we get 0. Say map.set C, value plus 1. Then we hit A, okay. So we'd add A1 to the map. So we do our whole thing, then we'd add A1 to the map. Then we go to the top, we'd say, does it already have C? Well, it does, which is A. So we delete it, and then we would add the current character to the map, and then we'd go to B. We don't have B, so we add it to the map, and then at the top we would have A. We would decrement it once, add it, then add it back to the map. So with this, say if map.has C, then we want to do map.set C map.get C -1. So is A in the map? It's not, so we add it to the map. Is A in the map? No, so we add it to the map. Is A in the map? Yes, so we decrement it down to 0. So we decrement it down to 0. And then we add 1. And then we check if B is in the map. It's not, so we add B. We check if A is in the map. It is, so we decrement it, and then we add it again. So we have 1. Check if A is in the map. It is, so we delete it, and then we add it. Check if B is in the map, we delete it, and then we still have A, B. Check if exclamation points in the map. It's not, so we add it. Now we have a max of 3. We check if B is in the map. It is, so we decrement it. And then we add it back because we had to have exclamation point B. So I think this does work, except we're missing the decrement part. We're actually using the occurrences though. So it's like if map.get C 0, say map.delete C. So does this work? So we'd have if we add P, W is not exist, we add W, we delete W, then we add it again. Things we should have deleted P though. Then we add K. I think the map structure is too different from what we're actually mapping. I think we need to use something just like linear like this, like literally the original sliding window pattern. We add, let's say we iterate through, right? We want to do a sliding window pattern, right? The window is always going to be sliding down. So when do we want to restart? When W already exists. Right, so if W exists, we want to iterate up to that point and toss it away, and then we'll take the math.max. So sliding window, iterate through string. Right, right? We could keep a subarray. We'll just keep subarray. We'll iterate through the string. We'll say if C in subarray, iterate until C and remove elements. Up until and including C and remove elements. Then we can just take the max of subarray. So we iterate through the string. P is not in the subarray. Else add to subarray. So we add P to the subarray, add W to the subarray. W is in the subarray, so we iterate until and including W. And then we remove those elements, and then we keep going. K is not in it, so we add K. E is not in, so we add E. Then we W iterate until we find W. We do, we remove it. So we have a subarray. This we iterate through the string for const C of S. Say if C in subarray. So if subarray dot includes C. Right, you want to iterate until and including C. But before we do that, we'll just say subarray dot push C, and then we'll take max equals math dot max or subarray dot length, and we'll have let max equals negative infinity. So we're going to iterate until and including C. So what that means is while subarray dot length is not equal to 0 and subarray sub 0 does not equal C, right? Then we want to do subarray dot shift, and since we want to include the last element, we'll say if subarray dot length is not equal to 0. One last time, do subarray dot shift again. And then we can return max. So we get 2 here. Oh, subarray dot shift, and then we actually we could exclude removing the last element. That way we wouldn't, because we want to include it again. So you have A, right? Subarray dot include C, right? Subarray does include A. So while subarray length does not equal 0, and subarray sub 0 does not equal C. So it looks like while A does not equal B, while A does not equal A, right, we still need to remove one character. So then we would have A, and then we would actually remove one A. We'd have AA is not 0. It's not 0, and it doesn't equal A. So we don't do anything, but we do remove we would have A. Oh, it does not equal C. So we would remove that A, and then we go to B. Well, since we go to B, that actually wouldn't be good because we never get to do AB. So maybe we can have a variable like removed. If we didn't remove anything, then we need to remove at least we don't need to. So we're into A, right? There's nothing to remove because we never pushed it, so we still have A, right? Then we go to else, we have B, then we have A, right? But if we didn't remove anything, we want to remove at least. We end up not removing anything, so our array is still A, B. Then we have B, and so array does include B. Then you say, well, A does not equal B, so we have A. We don't remove B. Let me add exclamation point. Oh, we end up removing A. So actually obey the sliding window pattern. So we need to have, we add A, right? Then we say A is already here, so we want to remove everything up to this.